Okay, here is our sixth free response from this batch, and this one I would say is not, it's not terribly likely you're going to see one just like this. There's usually kind of one wild card in there. It has to do with basic derivatives, continuity, limits. Not too uncommon to see something piecewise somewhere on the test, but anyway, here we go. This will provide a decent review of some of the stuff we've done that may even help you in the multiple choice. So for the first part here, is f continuous at x equals 1? Why or why not? Well, this goes to the idea that for a function to be continuous at x equals 1, what has to happen is the function from the left has to be heading in toward a particular y value, and the function from the right has to be heading in toward that same y value. In other words, the limit from the left equals the limit from the right. That's enough to say that the limit will exist, but you could still have a situation like that where maybe the y value is down here, and that would of course not be continuous. However, to be continuous, the limit from the left equals the limit from the right equals the actual y value at that particular x value. So if we're going to be continuous at x equals 1, we want to find out what the y value is at 1. So let's find out what f of 1 is. And because our function includes 1 here, we're going to plug 1 into that upper polynomial function, the very friendly quadratic. So it's going to be 10 minus 2 times 1 minus 1 squared. So that's going to be 7. Now, the limit as x approaches 1 from the left is just going to be found by direct substitution. In other words, we've got this polynomial thing, the x squared guy here, the upper branch, and then it's going to be this e to, this exponential function over there. So the limit as x approaches 1 from the left, you just plug 1 into the upper one, which we know is going to be 10 minus 2 times 1 minus 1 squared, which of course is 7. And the limit as x approaches 1 from the right is going to be 3 plus 4 times e to the 1 minus 1, which of course is 3 plus 4 times e to the 0, e to the 0 being 1. We've got the limit from the left equaling the limit from the right equaling the y value. So yes, f is continuous at x equals 1 as the limit as x approaches 1 from the left equals the limit as x approaches 1 from the right equals f of 1, so that's all you'd have to say there. Okay, for part B, we're going to try to find an absolute min and an absolute maximum value of f, so we got to make sure we report in on the y values, not the x values that get those y values, on a closed interval between -2 and 2, and show the analysis that leads to your conclusion. So when you hear absolute min and absolute max and you see closed interval, that should be a dead giveaway that we're going to need to check our endpoints. So we want to get our critical numbers, which are going to be found when the derivative is either equal to 0 or undefined. So we should probably look for the derivative of this thing, and in doing so, it's piecewise, but that's okay. You just take the derivative of both parts. So let's find f prime of x. So we can kind of think of it, we'll define it in two ways. We're going to look at the upper branch. The derivative of 10 minus 2x minus x squared is going to be -2 minus 2x for x is less than or equal to 1. And then f prime of x is the derivative of the exponential part. The derivative of 3, of course, is 0. The derivative of 4e to the x minus 1 is just 4e to the x minus 1 times the derivative of the exponent. Well, the derivative of the exponent is just 1. So we're in business there. So it's just going to be 4e to the x minus 1, and that's for x's that are greater than 1. So we want to check and see where this thing is, where the derivative is equal to 0. Well, this first guy, -2 minus 2x, is equal to 0 if -2 equals 2x, which means x equals -1. That's on our interval, so that's a good number to know. And then 4e to the x minus 1, set that guy equal to 0, and you're not going to get any critical numbers there because there's nothing that's going to make e to the x minus 1 equal to 0. Divide both sides by 4 and you get e to the x minus 1 equals 0. Remember, e to the x never goes to 0. So that doesn't get us any critical numbers. However, we want to think about what's happening. We're talking about the slope of this function, which I just, I drew some scribble up here. I have no idea exactly how this thing looks. But we want to check to see any points of non-differentiability. Well, the derivative is defined for x is less than or equal to 1 everywhere. That's just going to be a nice guy. And the derivative is going to be defined for this part. That's all fine. But we have to check and see whether the derivative at 1 is kind of the same from both sides. So in other words, f prime at 1, you would plug into this top thing and you get 0, right? Negative 2 minus 2 times 1. Now you're going to get negative 4. But what's happening from the right side, those slopes, as x gets close to 1, kind of like the limit of f prime of x as x approaches 1 from the right side, that's going to be 4 to the 1 minus 1, which is 4 to the 0, which is 1. And you see how the slope on the left side was approaching negative 4, or is negative 4, and then the slope immediately becomes a slope of 1. So that means there must be a sharp corner thing going on here. So maybe the graph looks like this and has a slope of negative 4, and then suddenly darts and becomes a slope of 1. So this piecewise function, although it is continuous, has a sharp corner. And obviously, this part wouldn't be a straight line. It's it's an upside down parabola, and then maybe it has a sharp corner and becomes this exponential curve. Something like that is what this function might look like. So we've got critical numbers of x equals 1 because the derivative from the left doesn't equal the derivative from the right. We've got a critical number of x equals negative 1. That would probably be like this point up here. So this would be x equals negative 1. This is x equals 1. But then we've got our endpoints at negative 2 and x equals positive 2. And again, I have no idea of the relative heights of the y values of these things. So I don't know which one's going to be our absolute min or max. But we now have 4 numbers that we can test. So what we need to do is check our y values at the endpoints and at these two critical numbers. So a lot of times they kind of show you this in the rubrics as just, they make like a little chart here for x values and f of x. And let's see, at negative 2, we would need our x value for the function. I'm sorry, our y value for the function. And because negative 2 is less than 1, we'd be plugging that into the top function. So it would be 10 minus 2 times negative 2 minus negative 2 squared. So we would evaluate that. Let's see, that's going to be 10 plus 4 minus 4. So that's 10. And then our next critical number up is negative 1. And negative 1 again is less than 10. So we're going to, I'm sorry, less than 1. So we're going to again use the top function. So 10 minus 2 times negative 1 minus negative 1 squared is 10 plus 2 minus 1, which is what, 11? And then, so we have 11 there. And let's see, at 1, which is our next critical number, we have, for at 1, the function is still valid, so we're still using the polynomial. So 10 minus 2 times 1 minus 1 squared, which is 10 minus 2 minus 1, which is 10 minus 3, which is 7. And lastly, at x equals 2, we've got to use the exponential function because that's a value that's greater than 1. So we're going to get 3 plus 4 times e to the 2 minus 1. 2 minus 1, of course, is 1, so it's 3 plus 4e. So now, not the very friendliest number, but remember e is, I always say it's a number a little less than 3, it's 2.718. But if you take 4 and multiply it by 2.718 and then add another 3 to it, you're certainly going to be, because even if it was only 2, it would be 4 times 2, which is 8 plus 3 is 11. You would be tied with this guy, but since e is bigger than 2, you're going to be bigger than this guy. So this is our absolute max. So our max value, absolute max value is, let's see, 3 plus 4e, and our absolute min value of the function is the smallest of those guys, which is 7, which occurs when x is 1. That's all you need. All right, for part C, I think this is pretty much of a gimme. It's not terribly difficult. It's a little bit funky because they want us to integrate this piecewise function, which I copied over here. We haven't integrated many piecewise functions in class, maybe not any of them, but it's pretty intuitive. As long as they're continuous, which we proved in the first part, all we're going to do is get the integral for this kind of left portion before the sharp corner that we found in the last problem, and then integrate from there to the right. So this sharp corner, again, occurs when x is 1 because we found that the derivative, the slope from the left, didn't equal the slope from the right as we got in toward x equals 1. So we're going to integrate this curve, which is the upper branch, the polynomial, from 0 to 1, and then we're going to integrate the lower branch from 1 to 2 and just add them together. And, kind of think of it breaking it into 2 areas. And we can, kind of get this area over here in the first chunk, and that area over there in the second chunk. And so we'll call it like region 1 and region 2. So let's integrate from 0 to 1 of 10 minus 2x minus x squared dx, and then we're going to add that to the integral from 1 to 2 of 3 plus 4e to the x minus 1. Parentheses around that with the dx. It does say to find the value, so this is, we're going to have to actually do the integration here. So 10x minus 2x squared over 2 is going to be minus x squared minus x cubed over 3 between 0 and 1 plus 3x. Now the integral of 4e to the x minus 1 is just going to be 4e to the x minus 1. No need to do a u sub because the derivative of x minus 1 is just 1. And that junk is going to be between 1 and 2. So let's see if we can evaluate this without screwing up. Plugging a 1 into this guy here, we're going to get 10 minus 1 minus 1/3. And then we're going to subtract what we get when we plug in 0, which of course will be 0. Over here, we're going to do 3 times 2 plus 4e to the 2 minus 1, minus when we get when we plug in 1, which is 3 times 1, plus 4e to the 1 minus 1. You might wonder why I'm showing all that work. It's basically just insurance against screwing up. Trust me, it's probably worth it. So 9 minus 1/3 is 27/3 minus 1/3, which is 26/3. And then we're adding to that 6 plus 4e to the first, which is just 4e, minus 3 plus 4e to the 0, which is 4 times 1, which is 4. Notice we're subtracting that sum. So we have 6 plus 4e minus 7, which is negative 1 plus 4e. And then, of course, 26/3 minus 1 is like 26/3 minus 3/3 plus 4e. So we get 23/3 plus 4e. And that is our area of both region 1, which was this stuff, and region 2, which was that stuff.